Scientists announcing today they heard and recorded the sound of two black holes colliding in outer space, a billion light years away. They say it's the first direct evidence of gravitational waves, ripples in space-time, if you will, that Einstein predicted.
Many of you have probably heard of the big discovery that took place on February 11th. That discovery was gravitational waves. But what are gravitational waves? Why are they so important? Why are scientists getting so excited about them? Did you know that Einstein predicted the existence of gravitational waves in 1915? That's about a century before they were actually detected. And thanks to modern technology, scientists have confirmed Einstein's prediction. Okay, so how do we understand what gravitational waves are? Well, I have a diagram here that I think will help. So I have a bowl of water here, and I have a small rock. When I throw the rock into the water, we get a splash. The rock symbolizes a cosmological event, like two black holes colliding. Now, when I throw it in, we get a splash, but we also get ripples. Ripples of space-time. These ripples are what scientists are so excited about. Gravitational waves, as they travel, bend space in one direction and stretch it in another. So on February 11th, these waves were produced by the collision of two black holes, but they didn't just collide. They were spinning around each other at incredible speeds. This spinning motion warped space-time and caused waves that traveled across space-time at the speed of light. Well, that's all well and good, but how were we able to detect them? The instrument responsible for their detection is called LIGO. LIGO is an observatory dedicated to gravitational wave research. The device is called an interferometer. An interferometer is basically a device consisting of two beams which are set perpendicular to each other. At the end of each beam there is a mirror. What happens is light is shot out at the instrument and it's caused to split into two beams of light, which travel across the beams of the interferometer. When they hit the mirror, they bounce back and are caused to reconverge into one beam. Now, that one beam hits a sensor, and if there is no signal, that means that the two beams reconverged at the same exact time, and they cancel each other out, and there was no signal. But on February 11th, what happened was they got a signal. Gravitational waves, as they passed over the LIGO interferometer, bent space. They stretched space. So light is traveling at the same speed, but when the light hits the space, the stretched space, or distorted space, it has to travel a little bit farther because the space is stretched by gravitational waves. That is how they were detected, and on that day, LIGO scientists were very, very excited, and they had good reason to be. In 1888, radio waves were discovered. This provided a new way to look at the universe. Gravitational waves are basically the same thing. You can look at it through a different eye. Gravitational waves are key to stepping up to the next level of human intelligence, to find out how black holes form, find out how the universe formed, and to find out how Einstein came up with his theories and how to further improve them to make a theory of everything. This is a game changer. This is groundbreaking. It is so exciting. I can't wait until we can further advance through gravitational wave astronomy and be the species we're supposed to be. The species who questions and discovers, and through those discoveries harnesses that, applies that, and advances. This is why gravitational waves are so groundbreaking.